Commerce on the American river system is a major way of moving bulk materials, including coal, ore, grains, petroleum, chemicals, and many other cargoes. Carried in a number of barges lashed together, they are propelled by a towboat. These boats are rugged, simple, and very powerful. And while some use Z-drives or thrusters, most are equipped with conventional propeller shafts and multiple rudders. Early in the 20th century, nobody worried about water entering the hull through stern glands because there weren't any. Cotton was the main cargo, and the trip took a little longer. Crews didn't care much about pumping oily bilge water over the side. Oil pollution wasn't important. The water you see here leaking past this stuffing box mixes in the bilge with oil from the machinery, and it must be pumped overboard through an oily water separator. This adds cost and the risk that some oil will still make it into the river, an invitation for a pollution violation. This yacht can't avoid navigation in shallow draft conditions where dirty water is expected. The last thing the captain wants to think about is tightening packing glands or worry about leaking seals. Thordon needed a seal to go with its long-life bearings, but it had to be better than any other seal available. It had to be able to operate in case of seal face failure, and it needed to be able to last for the life of the vessel. The design challenge at Thordon was to develop the best possible seal that would cover the shaft sizes from 2 to 14 inches or 50 to 300 millimeters. The emergency seal had to permit continued shaft operation in the event of any failure. This emergency seal is made from a special grade of polymer known as Thorflex. Lauren places the seal wedge ring into the rotary seal holder. This arrangement is designed to drive the rotary face squarely and securely without distortion. The bellows must function as a spring as well as a static seal and a torsional anchor for the stationary seal face. It's made from a new generation Thordon polymer called PT80. Next, the stationary seal ring holder is fitted to the inboard end of the bellows. Both seal faces are made from silicon carbide. This extremely hard material operates with a water gap so small that abrasive particles are excluded. Thordon's parent, Thomson Gordon Group, has been making mechanical seals for over 20 years, and their culture of quality runs deep. The TG100 seal got its name from lab testing during the company's 100th year in business. Metal parts for this seal are made in the company's Polish factory and shipped to Canada for completion. Louisville, Kentucky is in the heart of America's river country. It is also the location of Thordon's largest distributor in America and their associated boat building yard, Marine Builders. The shipyard is located on the banks of the Ohio River. The focus of attention today is on the 1,320 horsepower twin-screw vessel John Wiley. The clamp rings on these seals were delivered with a slight undersize to accommodate the possibility of undersized sleeves. This boat is clearly a 100% Thordon-equipped vessel. The white Thordon SXL rudder bearing should last for at least 15 years in dirty water. The port shaft has just arrived in the yard from the shop where corrosion-resistant hard coatings were applied and machined to a finished diameter. The shaft will be inserted until the inboard end is roughly even with the stern tube flange. This yard uses WD-40 on the shaft to ensure smooth passage through the bearing, but engine oil also works. Jim Bright has served on a number of riverboats in his career. His last job was chief. He knows the river and its people well.
Hi, I'm Jim Bright with Marine Industries. Today we're installing a TG100 seal in this new construction boat. The customer chose the TG100 over the competitors because of our come home feature. We have an exclusive emergency inflation seal that once deployed, the operator of the boat can continue to turn the shaft, maneuver the boat, and bring it back to a safe port. We think this is a really good feature.
To guide the seal housing into position, these men are fitting two threaded guide rods into tapped holes in the stern tube flange. You can see that the gasket has been fitted. The seal housing, including bellows, has now been moved into position along the guide rods. It can now be bolted to the stern tube flange. Third-generation engineer and founder's grandson, Matthew Ivanzik, joins Jim for some hands-on experience in the shaft alley. Once the seal gland has been secured, the guide rods are now threaded into the seal gland. They will be used in drawing the rotary seal unit into position. Jim is fitting the 2 eye bolts to the rotary seal assembly. They will slide over the guide rods and pull this assembly to the proper position, compressing the bellows the correct amount. The shaft is being moved forward now so that the rotating components can be added. The bellows must be compressed the required amount to provide the correct static spring force to the faces. The nuts are tightened evenly. Proper compression of the bellows is important, and the dimension is given for every seal size in the installation manual. A tape measure is good enough for setting the bellows compression. Jim checks dimensions on both outboard and inboard sides. Now that the rotary unit is in position, the wedge ring can be fitted. These socket head screws should be tightened in a sequence and torqued to ensure that the rotary seal ring holder is not distorted. The complete installation of this seal on one shaft line took only 2 hours. Designed to last for the life of the boat, the TG100 River Seal is another product made by Thordon for the boat owner who would prefer not to spend money on spare parts.